So, good day everyone. We are here to discuss about the modern diesel engines, specifically the marine diesel engines, their constructions, operations, as well as the newly designed inventions and the advancements of marine diesel engines in today's generation. So, my name is Susto Geneville B, and I'm from BS Maritime Bravo, along with my crew teammates, Briggs Bilbao, Ranilo Osinar, and Clint Eulogio. So many advancements are being made in the world of diesel technology today to help things be more efficient and more environmental friendly. So here are some of the inventions today for modern marine diesel engines. So here is Scania D113 marine diesel engine, a newly designed marine diesel engine which can withstand the toughest conditions. Scania's compact and lightweight engines are built to last. The DI-13 is built on a compacted graphite iron engine block with a simple wastegate turbocharger, allowing for top performance. The engine offers optimal and more accurate fuel delivery efficiency by its common rail extra high pressure injection system and Scania's engine management system. So expect greater torque, less noise, and improved fuel efficiency. The DI-13 is EPA tire or Environmental Protection Agency for emission reduction compliant at certain ratings. So, with a horsepower of 700 to 900 HP, RP that runs 2,300 with a dry weight of 2,832 and with a displacement of 12.7 liters.
So now let's talk about Scania DI-16. So it is a marine diesel engine model, a 16-liter V8 or has a 8-cylinder block which deliver up to 1,500 HP. Components are mostly made of graphite rock. These engines offer all the great features available in the DI-13, but with a greater power and torque. Scania DI-16 ensures that its engines are easy to install and repaired, provided with a quality and durability of the materials. With the separate cylinder head so that a technician can change a head on site, except greater reduction of vibration, noise, and much higher running efficiency and fuel efficiency with advanced electronics control system for low carbon emissions. With a horsepower of 1,000 to 1,150 HP, RPM 2,300, dry weight 3,659 pounds, displacement of 16.4 liters, piston arrangement is V-type with 8-cylinder.
Good day, my name is Ronald Labrosinar, and today we're going to discuss the Volvo Penta D4 and D6. So it has a horsepower about 150 to 440 horsepower, and also the RPM has 3,400 to 3,700. So its dry weight is about 1,444 to 1,742 pounds. Displacement ranging about 224 to 336 cubic inches or 3.7 to 5.5 liters. So the Volvo Penta D4 and the Volvo Penta D6 DPI or Digital Pressure Indicator is a newly designed modern marine diesel engine with a horsepower might be lower than the other, but ranging only from 150 to 440 horsepower, but with a flashing RPM of 3,500 plus. So it is equipped with an enhanced common rail fuel injection systems, superchargers, turbochargers, and charged air coolers. So the Volvo Penta has also an advanced electronic control system that allows for high fuel efficiency with a low carbon emissions. So the Volvo Penta D4 and D6 allow for more pleasant run on the water with reducing with a reduced vibration and noise.
Hi, my name is Clint Eulihio, and for this video, I'll be discussing the MAN V 2000 HP Marine Diesel Engine. The MAN V 2000 HP Marine Diesel Engine. So, the Emotion Diesel Hybrid System is unlike any other listed here. So, the hybrid parallel so there we have a hybrid parallel propulsion. So the hybrid parallel propulsion system allows shippers to run the various mode such as fuel diesel, tradition propulsion mode, diesel electric navigation mode, and zero emission mode. So under the dedicated sport fishing hybrid package, the system enables unparalleled fuel savings and sound reduction. So allowing for 4 hours of runtime in zero emission trolling mode. So once those 4 hours are up, so the operator can restart the operator can restart the diesel engine and the fast recharge the lithium battery packs within just 20 minutes. Pre-assemble and ready for installation. It can also be combined with a variable speed generators to increase acceleration. So we have here the horsepower at with a horsepower full range of 850 to 2325 HP and RPM of 2300 and dry weight of 5,950 pounds, displacement with 1,476 cubic inches. So that's for our MAN V HP Marine Diesel Engine.
So, good day. My name is Briggs Robin Estorinos Bilbao from Bachelor of Science Marine Engineering 3 Bravo. For today, I'm gonna discuss with you the different functions of the engine safety and protection. So, let's start. So, the propulsion system of a ship is what keeps it moving when at sea. The marine engine, which is regarded as the beating heart of any ship, carries the full burden of moving the ship forward. The propulsion engine of a ship experiences a variety of load and pressure throughout its lifetime, including adverse weather, difficult in maneuvering, and failures. Of course, without an engine, a ship is practically a dead ship. Several of the protection mechanisms are installed to shield the marine engine from a serious damage and malfunction in order to prevent any major loss or damages. So the first safety equipment is the alarm. In case of deviation of engine parameters from a set value, an audible and visual alarm will sound, which will give an early warning of the problem. So the marine engine alarms and trips. So we have cooling water, temperature alarm, jacket cooling water, low pressure alarm, air cooler, high temperature alarm, fuel oil, high temperature, and lastly, fuel oil, low pressure.
So good day, my name is Ronald Labra Sinar, and for this topic, we're going to discuss the slowdown, engine slowdown. So slowdown, it is the next stage of protection when the action taken are not sufficient to control the ongoing problem. Hence, engine slowdown is done to counter the disturbed parameters. So engine slowdown occurs, or engine slowdown automatically occur when there is a problem to the system to avoid severe damage later on the stages. There are different engine slowdown. situations like lube oil pressure. Lube oil pressure falls to 1.5 bars. Camshaft pressure falls to below 2 bars. There is no flow of piston cooling media like water or oil, and also oil mist detector or main bearing sensors has been activated, and also the lubricating oil temperature inlet is high, uh, greater than 60 degrees Celsius. So these different situations might be slowdown of the engine. So first, let me discuss to you the lube oil pressure. So the lube oil pressure falls to 1.5 bars. So it is very inefficient if there is lower pressure of lube oil. So dapat 1.5 to 4 bars and 1.5 to 4 bars yung pressure ng lube oil to have an efficient lubrication to the engine. Also, the camshaft pressure falls to below 2 bars. So I think it is not proper that there is a falling pressure of the camshaft. To avoid this, it is need to have 2 bars and above. So also there is no cooling of piston. There is no cooling in the piston like water and oil. So we all know that cooling is very important in the engine. So without that, it can cause severe damage to the engine. So the piston and the cylinder liner might have friction, causing to damage the engine. So also it has the oil mist detector and the main bearings sensors has been activated. So the oil mist is created when the lubricating oil splashed with the moving and rotating parts of the engine. It is very napakadelikado nito kasi if there is a oil mist, it can cause a fire, causing to its crankcase explosion. So next is the lube oil temperature is greater than 60 degrees Celsius. We all know that the lube oil temperature inlet is only for 45 degrees Celsius. It is not lower or higher to have an efficient lubrication to the engine.
So number 3, we have shutdown. So the main engine automatically shuts down when there is a high fluctuation in the engine parameters or has prolonged alarms which can harm other systems of the engine. The shutdown protective devices cut off immediately the fuel supply and the engine stops. So shutdown occurrences are as below. So main engine will shut down because there is a very high jacket cooling water temperature which is above 95 degrees Celsius, and according to our studies, the jacket cooling water temperature must be at 70 degrees Celsius to 80 degrees, and exceeding that temperature will never be a cooling water medium anymore. So next we have the low jacket cooling water pressure, which is less than 0.1 bar. No flow of cylinder lube oil. So when there is no flow of cylinder lubricating oil, so there will be presence of friction in the cylinder liner bearings, which can cause wear and tear to the materials. Finally, we have the thrust block temperature, very high, more than 90 degrees Celsius. So this can also cause damage to our main engine, which can cause it to shut down. But there are also other causes that the main engine will shut down. Malfunction in the fuel systems, lubricating oil systems, and the cooling water systems, and some of that are causing the main engine to be shut down.
Hi, good day. My name is Clint Iulio. So for this video, my part for this video will be discussing the last type of the protections on a ship's marine engine. One type of the protection of the ship marine engine will be the starting interlock. So this is the last type of protection on ship marine engine for our discussion. So here stated that starting interlock, this will not allow the engine to start from the standstill condition if some important system within the engine has not been operated or arranged properly. So interlocks are provided so that the engine can be started or engine can be started or reverse only when only when certain condition have been fully filled. So when there is remote control of engines, it is essential to have interlocks. This reduces the possibility of engine damage and any hazards of the to the operating personnel. So there are three marine engine interlocks, which are the turning gear engage interlock, auxiliary blower of interlock, and lastly the lube oil and other important pump not running interlock. So first we have a turning gear engage interlock. So a turning gear interlock, so this device prevents the engine from being started if the turning gear is engaged. So next marine engine interlock will be the auxiliary blower of interlock. So auxiliary blower interlock. So auxiliary blower interlock, the auxiliary blower is provided in the auxiliary blower is provided in the case of constant pressure turbocharging. And the last will be the lube oil and other important pump not running interlock. So lube oil. So the lube oil. So lube oil and other important pump and not running interlock. So piston cooling, pressure, and jacket water pressure and important parameters must be above the required minimum. So this is the main this will be the main lube oil pressure. So this marine engine interlock are belong to the last type of protection on the ship marine engine. So the interlock. So that's for our video presentation. So that will be the last part for our video presentation on the different types and protection of protection on a ship's marine engine. And thank you for listening and God bless.
Good day. My name is Ranal Sunar from BS Marine Engineering 3 Bravo. So in today's video, we're going to discuss the different engine safety interlocks. So let's discuss first the engine safety interlocks. So engine safety interlocks is done as a precautionary measures to prevent damage to the engine while starting. If there were an oil or water leakage, interlocks are the blocking device which ensure that the engine is started or reversed only when some conditions are fulfilled or satisfied. So in the main engine, interlocks are provided so that the engine can be started or reversed only when certain conditions have been fulfilled. When there is a remote control of engines, it is essential that it has interlocks. This reduces the possibility of engine damage and any hazards to the operating personnel. So first is the turning gear interlock. So it prevents the engine from being started if the turning gear is engaged. It blocks the starting air from reaching the engine. So the turning gears interlock is an important thing that it prevents the admission of the starting air to the engine cylinders when the turning gear is engaged. If the starting air is admitted with the turning gear engaged, then the turning gear along with the motor will fly off puncturing the bulkhead. So the interlock is necessary to prevent accidents. So the second is the running direction interlock. It prevents the fuel from being supplied if the running direction of the engine does not match the telegraph. An interlock also prevents starting of the engine if an attempt is made to start the engine before the reversing has been completed.
Hi, my name is Clint Ilio. So my part of this video will be explaining the starting air distributor in the end position and the main lube oil pressure. So here in starting air distributor in the end position, this prevents starting from taking place if the shifting of the distributor has not been completed. So it is the part of the starting air system responsible for providing pilot air to starting an air valve as per the correct starting order. So for example, 6-cylinder engine. So the injection timing of all cylinder is timed according to the firing order. So as we already know the firing order, right? So for an inlet 6-cylinder engine, a firing order of 153-6-24 ensures that more power is produced without putting unwanted stress and opposing forces on rotating shaft. So next will be the main lube oil pressure. So the main lube oil pressure rather. So piston cooling pressure, jacket water pressure, and important parameters must be above the required minimum. So before that, the purpose the main purpose or the purpose of a lube oil system is to continuously provide cool, clean oil to the bearings and gear at the proper pressure, temperature, and flow rate, right? So therefore, the major components of any lube oil system are as follows, like reservoir, the main and auxiliary pumps, the back pressure control valve to bypass excessive flow back to the reservoir if PD pumps are selected. Coolers with temperature control valve to control temperature being supplied to the bearings, and filters with differential pressure monitoring. And if ever those important parameters are not above the required minimum, so the following alarms may occur. Like for example, the lube oil pressure alarm. If ever piston cooling pressure is not above the required minimum, the lube oil pressure alarm, the lube oil sump low level alarm, the lube oil pump trip alarm, and for example, jacket water pressure is not above the required minimum, alarm may occur, like for example the jacket water low pressure alarm, jacket water pump standby start alarm, the jacket water high temperature alarm, and other alarms may occur if ever those parameters is not above the required minimum. And the main one of the main example here, if ever those alarms and if ever those alarm is not taken an action, if not, will be take an action. So if ever there is no action will be taken, rather, so our main engine will be stopped or out of power, or maybe or it will be stopped um if if ever our important parameters is not above the required minimum, and those alarms will exist and not be taken an action. So our our main engine will will stop operating.
So number 5, we have the auxiliary blower interlock. So auxiliary blower interlock is provided for constant pressure turbocharging. It should be in auto mode before the engine can be started. So auxiliary blower at the time of starting the auxiliary blowing is to be put on in auto mode because of no scavenged air present, or else it is difficult to start the engine without air. That was also the reason why black smoke occurs at that time of starting the engine, and due to the less quantity and quality of air. So next, number 6, we have the air spring pressure interlock. So it is provided, and if the exhaust valves are operated by air spring pressure or pneumatically operated, there should be sufficient air pressure before the engine can be started. Otherwise, exhaust valve may not close while running. So in other words, in case of this present generation, we have engines using exhaust valves which is shut by air spring. So the air spring pressure must always be maintained, or else the exhaust valve may not close, because the air spring must be provided with sufficient air pressure so that the exhaust valve will be easily closed and will not be always be open. In times when scavenging of air, or the removal of unwanted gases, with enough pressure in the air spring, it will be closed automatically when the engine is running. And it's because it also to prevent fumes from flowing back into the cylinder, the combustion chamber, that can cause moisture and corrosion to the materials.
So, the next interlock, we have the fuel pump interlock. So it prevents reversing of engine if the fuel rack is not in its zero injection position. So the next one, we have the camshaft interlock. So it is a device which restricted the engine from starting if the camshaft is not shifted or changed its end position in compliance with the engine order telegraph. So the other safety interlocks, we have the control air interlock, camshaft lube oil low pressure interlock, safety air interlock, spring air low pressure interlock.
Hi, my name is Kilent Yulio and I am with my group, and for this video we will be explaining what is the types of indicator diagrams. So first, what is indicator diagrams? So it is stated here that indicator diagrams are used to assess performance of each unit. It is based on the indicator diagram that overall performance of the engine. So indicators diagram taken at regular intervals. If there is any difference, and it is important that the problem is rectified before starting. So indicator diagram. So the indicator diagram is very important to know the combustion in the cylinder and also adjust the engine. So the diagram is taken periodically from the indicator valve equipped on the cylinder head, and combustion condition is to be confirmed. So the compression pressure and maximum pressure in the cylinder can be presumed from the indicator diagram. So engine indicator is device used to take the indicator diagram, so which can be considered as a stethoscope for diesel engines. So indicator diagrams give efficiency of combustion in the cylinder. So condition of the running gear, at also it regulates in fuel pumping and injection and a lot of things. And with the help of these diagrams, we can determine and interpret the following, like the compression pressure inside the cylinder, the peak pressure generated inside the cylinder, the actual power generated, so faulty combustion chamber parts, of the particular unit, faulty injection parts and wrong fuel timing, and also the exhausting and scavenging process. So there are 4 types of indicator diagrams that can be taken from the engine cylinder to know the condition performance of the engine. Namely, the power card or power indicator diagram, the compression diagram, the draw card or out of phase diagram, and lastly, the light spring diagram. And now, the first type of indicator diagram that can be taken from the engine cylinder to know the condition and performance of the engine will be the power card or power indicator diagram. So what is a power card? So a power card, the taking of indicator cards, it allows the engineer to receive the more information about the combustion process. So it is stated here that it is via the draw or out or phase card. It also measures the cylinder power output of the engine via the power cards. And also check the cleanliness of the scavenging process via the light spring diagram. So a power card, a power card is taken with the indicator drum rotating in phase with the piston movement. So the area within this diagram represents the work done during one complete cycle to scale. So lastly, mean indicated pressure, the MIP, is obtained from this diagram to calculate power produced in the cylinder. So that will be all for the power card.
So the compression diagram. So the compression diagram is taken in similar manner to the power card, but the fuel shut off in the cylinder. So the height of this curve shows maximum compression pressure. So if the compression and the expansion line coincide, it indicates that the indicator is correctly synchronized with the engine. So reduction in height of this diagram shows low compression, which may be due to worn cylinder liner, faulty piston rings, insufficient scavenge air, or leaky exhaust valve.
So next is draw card or the out of phase diagram. So the draw diagram or draw card is used for measuring the compression pressure and maximum pressure and for evaluating the ignition characteristics of the fuel oil. So draw card is basically taken in a similar manner to power card with fuel pump engaged but with the indicator drum 90° out of the phase with the piston stroke. The diagram illustrates more clearly the pressure changes during fuel combustion. Fuel timings or fuel injector faults may be detected from its shape.
Now let's talk about the light spring diagram. It is taken similar to the power card and in phase with the engine and with a light compression spring fitted to the indicator. This diagram shows pressure changes during exhaust and scavenge to an enlarged scale. It can be used to detect faults in those operations.